I'd like to explain a potential problem that was pointed out by Corey a while back. This was maybe roughly a year ago. So at the time we used the software shiftbuilder to talk about staffing at Elmbrook Hospital. And these are the graphs that Corey saw that concerned him. So on the top you see the demand curve for Elmbrook at the time. I can't recall what the metric was. I think patients per hour for a period of 1 month from the beginning to the end of June, looking at weekends only. And here we're looking at weekends for a much longer period going into the end of February of 2017. And what we see here is that there is complexity here in the demand graph that we seem to lose, which appears to be a bug. And I want to try to explain to you why this is not a bug. So I wrote this out in an email that I never quite sent out, but maybe I can explain this in the video. So going back to sensor and this initial screen, you see here that most of the numbers are fractional. So here, for example, Tuesday at 11 a.m. at St. Joseph's Hospital sees 15.4 patients at the 80th percentile. But what does that really mean? We don't see fractional patients coming in an hour. The data set here for October 31st to January 30th of 2018 contains a set of whole numbers. There's always whole numbers presenting at any 1 hour to any facility. So how do we arrive at 15.4? Well, what happens is that there's no single number that corresponds to the 80th percentile. So we need to extrapolate between two numbers. Here, showing a quick example of this. Let's say we have this series of numbers and we want to find which one is, what is the 80th percentile. So we sort them first, right? And then you can see based on the fact that there are 8 samples, you divide the 100 into 8 fragments, in 8 sections, where the number 1 here corresponds to the 42nd percentile. So if you would ask what is the 42nd percentile, it would be 1. And here the 57th would be 2. So what corresponds to the 80th percentile here? Well, it's not 3, and it's not quite 4. It's somewhere between 3 and 4. And where it is exactly between 3 or 4 is an extrapolation. There's different techniques of how to extrapolate, but it's an estimate that's not a true number, meaning you'll never get 3.5 patients coming in an hour, but it's supposed to give you a better clue as to what this number is closer to. So if closer to 4, more likely 4, closer to 3, more likely 3. So what you can see in this example is the more numbers you have in the sample, the more percentiles will correspond to whole numbers and not to the extrapolation between them. Right? So if we had 36 values and then we sorted them, we can see that now the 80th percentile corresponds exactly to 3. So we wouldn't get a number like 3.6 or 3.7. So the end result of this is that the more numbers you have, the longer period of time you look at, the more likely you are to have a percentile that corresponds to a whole number. And so not corresponding to a whole number, like we do here, this is pseudo complexity. It's not a true representation of the total number of patients that come in an hour in a particular time. It is an interpolation between those whole numbers that appears complex. But really, the more data we present, the more accurate result that we get. And the accurate result is it's always a whole number. And here, when we look at a long period of time, you see all of a sudden that we are always gravitating to whole numbers. Hopefully, this explains it. If there are questions, I can send this document as well. Thank you.